Hello, Math 96. Today's Thursday, October 1st. Happy October. So we're going to continue in section 2.1, day 3. We're doing page 16. We're going to be doing examples 7 and 8. And then your homework tonight, there's no official graphing homework. I just need you to write your summary for the essential question above. And the essential question is, what's the difference between linear and nonlinear graphs? Okay, since Monday of this week, you should have 2 homework assignments done, either on your own graph paper or on pages 141 and 142 in the back of your white notebook, where I put some extra graph paper for when we do have homework that's for graphing. And you should have listened to section 2.1 recording, 2.1 day 2 recording, and this is 2.1 day 3 recording. You should also have completed the notes from those recordings onto page 14, 15, and 16 in your white notebook. Please just save everything. Don't upload an image into your digital workbook. We're going to start a new digital workbook next week, okay? So just hold on to everything for me. Okay, so this is example 7. This is examples for what we asked in you can see it at the bottom of the screen. What's the difference between linear and nonlinear graphs? So this is absolute value graphs. You should be very familiar with this from Algebra 2. So this is a nonlinear graph. So again, what you want to do if you're going to be taking a test like for college or the military, when you choose a number to put in your T-chart for X, you can pick any number that you want. But it's, if you're looking at the grid over here, we would want to choose like 0 and then numbers to the right, like 1, 2, 3. And you also want to choose numbers to the left of 0, like -1, -2, -3. That way you get an idea of what is happening on each side of the origin, on each side of 0, 0, of what the graph looks like. So I'm going to put 0 in the middle. I'm also going to choose 2 and 4. And then on the other side, I'm going to choose -1 and -3, just to show you that you can choose any number and you'll be able to produce a graph. Okay, so the equation is y equals the absolute value of 2x. So if we plug in for the x, so just reviewing in case people are struggling with T-charts, if we choose x, we put it right here and we do the math and out comes the value of y, right? And the absolute value comes out as a positive number. So we'll get started. Y is equal to, what's the absolute value of 2 times, and then right here I'm going to plug in this number, 2 times 4. So what's the absolute value of 8? That equals 8. The next one, let's change colors here for you. Y would be equal to the absolute value of 2 times, plug in the 2. What's the absolute value of 4? It would be 4. So when we plugged in this 2, we got 4. And the next one would be y is equal to the absolute value of 2 times 0. What's the absolute value of 0? Would be 0. So when we plugged in a 0, we got 0. The next one is y is equal to the absolute value of 2 times -1. So what is the absolute value of -2? Absolute values come out positive, so it's +2 when we plugged in -1. And the last one, when we plug in a -3, y is equal to the absolute value of 2 times -3. What's the absolute value of -6? Comes out +6. So then we have points that we can go ahead and graph. So this one would be 4, 8, 2, 4. And remember, we're putting these two numbers, x and y, together. X, right? Because that's at the top, x and y. 4 and 8 go together. This one is 0, 0. This one is negative 1, 2. And this one is negative 3, 6. And we put the points on the grid and you take a look at what your graph looks like. So the first one, over 4, 1, 2, 3, 4, up 8, 1, 6, 7. So you have to estimate it's about right there. Over 2, 1, 2, up 4, 1, 2, 3, 4. The next one is the point at 0, 0. So we're done with this one, this one, this one. We'll do this one next. Left 1, up 2. And the last one, left 3, 1, 2, 3, up 6, 1, 2, 3, 4, 5, 6. And you should remember from Algebra 2 that absolute values are V-shaped, shaped like a V. So I'm going to do my best to draw this through. Sometimes I don't quite hit the dots, and you guys are using rulers at home, so give me a little grace. I'm working just on this straight pad here. There we go. So there's a picture that should be a little bit straighter right there. It's a little wavy, sorry. There we go. So please make your line straight. So there's a picture of absolute value. You will not be tested at this time on absolute value, but I do need to go over it in this part of chapter 2. Make sure you know how to do the lines that are before. But that was a really good review for how to do what we call a T-chart or a table of values. Okay, and I'm trying to show you that in case you are faced with a situation where you have to graph something you don't know, then just pick some numbers and take a look at what the graph comes out to be. Okay, you can hit pause if you need a minute to write down your notes. I'm going to move on. Okay, so this is graph the parabola. Again, this is nonlinear. I'm pretty certain that some of this was probably missed last year due to the school closure in March. So again, same idea. You're going to pick numbers for the X and Y. We'll be doing a big section on quadratics and parabola later on in our notebook. So this is just a nice introduction. We need it for a few things that are mathematical computations that come up in chapter 2 and chapter 3. So we're going to go over some now. So I'm going to lead you with the numbers. So again, you always want to pick 0. And then let's pick 1 and 3. And we'll pick -1 and -3. Now let's see what happens when we plug those into the equation. So it's y equals x squared minus 5. Okay, so y would be equal to, plug in for the x right here. So 3 squared minus 5. You do the exponent first, that's 9 minus 5, so that equals 4. So when we plugged in a 3, we got a 4. So we'll graph the point 3, 4. Now we'll plug in 1. Y will be equal to 1 squared minus 5. 1 squared is just 1 minus 5. That equals -4. So when we plugged in a 1, we got -4. Plug in 0. Y equals 0 squared minus 5. 0 squared is just 0. You don't need it, so it's just -5. So that's the dot 0, -5. The next one, -1. Be careful here. You need parentheses anytime you plug in a negative number. So when we plug in this one for -3, we always, always, always put the number that you're substituting in parentheses. That's a negative number that you're plugging in. You have to have parentheses. Okay, so what's -1 squared? That's -1 times -1. That's a +1 minus 5. That would be equal to -4. So this one's -1, -4. And this one is -3 times -3 is 9 minus 5 equals 4. So So the last dot is -3, 4. You can always hit pause in the recording so that you can get caught up. Okay, so the first dot is over 3, up 4. The next one is over 1, down 4. This one is 0. For this, I always say 0, don't move. And then this is the up or down. So don't move, down 5. Don't move, down 5. The next one is -1, down 4. Whoops, I erased it. And the last one is left 3, 1, 2, 3, down. Left 3, up 4. Sorry, I read that wrong. 1, 2, 3, up, 1, 2, 3, 4. There we go. So when you graph a parabola, they are U-shaped. So quadratics. When you have something with an x squared, you get this kind of graph. Anything that has a square gives that kind of graph. So we're going to just start here and kind of swing it up. It's easiest to start at the vertex. And so this should be U-shaped, not V-shaped, okay? All right, that's the lecture for today, you guys. So the homework is, to write your summary for the essential question. So I need you, hopefully I left a spot. I did. At the very bottom of page 16 has a spot for you to write your summary. So what's the difference between linear and nonlinear graphs? So you graphed, the first two homeworks were linear, and these last two that we did today in the lecture are nonlinear. So hint, 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 a linear graph is a line. Straight line, we talked about that for the past couple days. Nonlinear graphs have curves to them, right? They're not a line. Okay, so write in your summary, please. Okay, see you tomorrow.